Hi, my name is hw5. Today I'm going to present my homework 5 to you. Um, First, I'm going to walk you through my code. In network2.py file, first I modified the function, the class of cost functions. For cross entropy cost, I added the derivative of the function. And then in the class likelihood, I modify the function of the log likelihood and the derivative of the function. For the class of active functions, I modify the softmax. I add the function of the softmax. For the class hyperbolic tangent, I add the arctangent function and the derivative of the hyperbolic tangent function. For the class rectified linear union, I add the rectified linear union function and the derivative of the rectified linear union function. Then I start modify the mean network class. So for the uh, so I will mention that since for the hyperbolic tangent, if the hyperbolic tangent is selected as the activation function for the output layer, the output value will be between 1 and -1. So the only cost function for hyperbolic tangent will be quadratic cost. So in the init function and the set parameter function, I write the if then loop. So if the activation function on the output layer is the hyperbolic tangent, then if the cost function is not quadratic cost, I print a message to the user to help them hyperbolic tangent only accept a quadratic cost function. Then I set the cost function equal to quadratic cost. Same thing in the set parameter function. For the regularization method, it has the parameter has two options, L2 and L1. So the select method is applied to all hidden layers and output layers. So for that, I modify the update mini batch function. So in update mini batch function, I write a if loop if the self-regularization equal to, and then you get this is the formula for calculate the weight. If L1 regularization, then the weight equal this formula. If the regularization is none, then the weight is this. Since the bias for different regularization is same, so I write in here. I also modify the total cost function. So if the regularization is L1, then this is the formula for the cost. If it's L2 regularization, then this is the formula for the cost. If regularization equal none, then this is the formula. For the dropout percent, since the dropout percent, the value should be between 0 and 1, and dropout consists in randomly setting a fraction rate of input units to 0 at each update during training time to help prevent overfitting. And in this problem, we assume the same dropout percentage is applied to all hidden layers. So to do that, I modify the few functions. First, I modify the init function. In the init function, I check for if the dropout percentage is 0 or not. If not, we set the dropout is true, then I create a list called dropout layer. This list will store dropout layers. Same thing on the set parameter function. Then I modify the feed forward function. In the feed forward function, I I check if the dropout is true, then I recalculate the output, um, the output of the network. Then in the XGD function, I check for dropout. So if the monitor evaluation cost is true and the self dropout percentage is larger than 0 or not equal 0, then the dropout is true. Then I also modify the function called update mini batch. In this function, I check if dropout is true, then I create new dropout layers and install this the dropout layer to the dropout list dropout layer. Also, modify the function called backprop. In the backprop, I check first I see if the is output layer or hidden layer. Then if the dropout is true, I because we only apply dropout layer to hidden activation layers, so I calculate the activation and then install the activation function to install the activation to this list activations layer by layer. Now I'm going to show you my code is working correct. So first let's restart. Then let's run all the code at once. So in this so here I have a total 12 experience for the first experience, for the first one to the first 8 experience, I got the same results like a professor gave. The regularization is none, the lambda is 0, dropout is 0. So first one is the activation function on the hidden layer, then activation function on the output layer, and the cost function. So in here, they all run correct. For the experience 9, the regularization is L2 and the lambda is 3. And the 10 is L1 regularization, they're working correct too. For the experience 12 and the 11, the dropout percent is 0.1 and 12 is 0.5, and they're working correct too. So thank you.